good afternoon. I'm Kelsey Martin. Since the Climate Change Action Plan demands sacrifices from each stakeholder group, each group faces implementation challenges. Population and consumption will struggle with reducing population growth rates in developing nations and setting lower GDP per capita growth targets. The carbon pricing scheme is aggressive but necessary, since achieving annual targets will require a funding mechanism. Implementing this scheme over an extended period of time can mitigate the pain experienced by affected parties. Also, necessary to fund ambitious research and development goals are steep taxes on fossil fuels, and early retirement of coal plants will also stress industry resources. These sacrifices are necessary because energy efficiency improvements are an area where compromise is not an option. Resources need to be made available to the transportation and construction industries to improve energy efficiency significantly year after year. Some of these resources will also go to renewable energy research, which will face policy resistance due to the high per unit cost of contemporary sustainable energy resources, as well as the high risk nature of investments in new technology. Climate change is not a far-off problem. It is happening now, and it is having very real consequences on people's lives. Climate change is disrupting national economies, affecting personal health, and costing us dearly today and even more tomorrow. But there's a growing recognition that affordable, scalable solutions are available now that will enable us all to move forward to cleaner, more resilient economies. We have the technology, we have the vision, and we have a hope for a better tomorrow.
So these are some key components that we all looked at. For the different sectors, for population and consumption, we looked at population and GDP per capita rate. We started off with a baseline of scenarios 1 through 3. The baseline was number 2, and that's at 11 billion people will populate the Earth by the year 2100. For GDP per capita growth rate, we started off with a baseline of 3%, and our results show that that continuing the scenario 2 will produce the greatest outcome, and also reducing GDP to 2.4%. Next, we have agriculture and land use, and these levers were the reduction in CO2 emissions from land use and forestry, which was measured by a percentage, and the baseline was 0, and we also left that as 0. Then there's a reduction in other gas emissions measured by a percentage. The baseline was 0%, and we raised that to 72% reduction in other gas emissions. For the fossil fuels, it was based on a tax subsidy scale. Taxes were negative, subsidies were positive. For coal, we had a baseline of 0, and we increased it to a -6 tax. For oil, we started off with 0, and we also changed it to a -8 tax. For gas, it was also 0 as a baseline, and we moved that to a -4 tax. For natural gas methane leakage, this is the reduction of that leakage, and it's measured in percentage, and we went from 3% down to 1%. For sustainable energy, it was also on a tax and subsidy scale. For renewable energy, it was at a baseline of 0, and moved to a subsidy of $8. It went from nuclear started off with a baseline of 0 and moved to $2. Biomass was also at 0, and we increased it to $5. New tech went from 0, and we increased it to $7. Energy efficiency, stationary, went from 1% to 3.5% per year. Mobile went from 1% to 2.5% per year. Carbon price went from $0 to $100. Revenue distribution for the following are fossil fuels 0 to 10%, sustainable from 0 to 80%, and public distribution increased to 10%.
Ooh, sorry. There you go. Do you want me to discuss?
Yeah.
Okay, this is a representation of our shift from resources over time from 2000 to 2100. And here we go.
Okay, so how it works. First off, we had to learn there's lots of trade-offs that we had to do. I mean, the first thing we saw in our group was that, the fossil fuels had to take a hit. So how could we lessen that hit as much as we possibly could while trying to gain our full goals? And what this came off of is, we're going to take a tax, we're going to have carbon pricing, but maybe let's get some of that money back into the fossil fuel industry so they can continue to create more technology and restructure their businesses in order to economically continue on. As well, if we look at the agricultural and land use, we also wanted to make sure that we weren't just focusing on carbon dioxide. That wasn't going to be the full solution. So we had to, again, create a win-win scenario where not only are we drastically reducing our carbon dioxide, but we're also focusing on the other gases and the other sources. Which brings me to the multifaceted energy efficiency. And on these two graphs, we have on the top is our final energy demand, and at the bottom is our overall cost of energy. So a strategy we took is making changes that not only reduce our demand for energy, that way we can catch up with technology on sustainable energy sources, but as well we can reduce the cost of energy to begin with. That way, as the fossil fuel industry and other industries are taking a hit, they're going to be okay and be able to keep going because the cost for them to produce the energy will be lower, therefore giving a better balance to the supply and demand.
Go back. Go to the rest of the parts.
And then our final is the shared emission reduction. And that's I've already kind of talked about that in the different gases, is we definitely took a big structure to where we had to not only focus on fossil fuels, but we had to focus on the other gas emissions, which we did a 72%, which helped a lot to kind of balance it and allow to keep our fossil fuel sector happy as we were able to really do solid, progressive, and fast-acting methods to reduce climate change effects and emissions.
And so then we have to look at the stakeholders that are actually in support of all these changes. And you look at the climate NGOs, and naturally they have an incentive to try and reduce the effects of climate change. And so they would be behind the majority of this plan. Then we have to look at the technology companies. And the reason that they're going to be supporting this proposal is because that industry is going to grow and thrive. As new technology is developed, you are going to be creating factories and high-wage jobs throughout the entire sector. And then you look at the general public. The general public will, of course, enjoy the advantages of a better climate because Miami won't sink. The islands will continue to exist, and we'll all have good, clean air to breathe. And if you look at it from the UN perspective, one of the big issues that drives competitive development and warfare, I guess, between different nations is the drive for energy, food, and other natural resources. And if we can get to a renewable energy state, the fight for those resources will diminish greatly and will take off strain on all of the nations and improve the UN overall. And that also impacts the government organizations because when you're not arguing with your neighbor about the water rights to a mountain, then maybe you can get along and help things along. Yep, and then finally we look at the implementation timeline, and that's actually going to start right now. You start looking at your coal, gas, oil, biomass, some of those industries that are already here, and they're already doing research, and they're going to continue to do that research. And for the existing industries, you're going to have a pretty early breakthrough year at 2020 because they're already up and running in industrialized nations, and they'll be able to hopefully meet that benchmark. For the older, longer sustaining traditional sources of energy, they'll hit their breakthrough years around 2045, which is also the point at which we were starting to see massive shortages in those resources anyway, and we'll hit the stop year by 2080, which is when we would be running out, and that allows us to reach our 2 degrees Celsius increase by the year 2100.
30 seconds to spare. Judges, one question each, and then we open it up.
Yeah, I'll go ahead. That's the first question. Thanks very much for your presentation. although you meet the target of 2 degrees at 2100, it strikes me that the trend line is still going upwards. And so the question is, does your proposal fix the problem at 2 degrees, or will we have to do something further in the out years after that? So have we leveled off, or are there things that you can imagine that we might have to do after 2100 to continue to address this problem?
Yeah, so in reference to which trend line, just so I can pull it up.
Go back to the very first one.
Temperature trend line.
It
You could predict what's going to happen to your line. We can't predict because the model only goes out to 2100, right? But given what you suggested, how would you predict that line to trend up or down? Is that what you're asking?
Yeah, well, the question is, do you think that the proposal that you made fixes the problem? Or do you think that it's maybe the case that additional steps will need to be taken to maintain the
Right.
temperature increase at no more than 2 degrees? That may be.
I think
In
the
out years.
right. I think the proposal from our perspective now tackles the issues. So we know what our issues are today. We can't really predict what kind of resources or what kind of new sustainable energies or research that we're going to be able to form in the next, 100 years or so. We can kind of gauge that information, but to say definitively that this is the end-all be-all solution for the next 100 years would be naive. It's definitely a policy, though, that we can revisit every 10 years to say, are we achieving our goals? Are we meeting our sustainability? Are we developing new technologies at the rate that we anticipate? Do we need to vamp up? Do we need to decrease? Those are all things that are flexible. As per the simulation, we can't indicate those changes.
Okay, we need to move on to the next question just because we only have 3 minutes. And your other teammates, not just the presentation group, can answer the questions.
Oh,
It strikes me that this alignment is actually fairly fragile. It would be, you're asking a lot of the participants, so I'm wondering how your staffing mechanism is going to support this potential over time.
Staffing, our staffing mechanism is basically based on combining people from different sectors, from different specialties to come together and think collectively. Like, we don't want to consolidate it to one particular body, but we want to encourage every participant from a particular sector or a stakeholder to come and collaborate together. So our participation is pretty diversified overall.
And I would add to that, one specific component that we added that we thought would be important would be the communications and the lobbying aspect. We do need a representative that is able to communicate with the different governments and the different sectors and be able to basically sell this plan and make sure that all the components are agreeable to the people that are going to be implementing it.
We also recommended allocating some of the funding in our implementation plan to both the research and development within companies and to education systems to produce more STEM majors that can perform the research.
Okay, last question from the
Yep.
judges.
My question, I thought, again, coming back to the fragility of some of this, I saw some of the changes were very dramatic on the levers that you were using. I'd be curious to know, in your simulation and leading up to the final simulation, which of these were the most important in making your final decision? Because some of these, like I say, they look pretty ambitious. Some of these seem rather ambitious. So I'm curious to get from you where you think the possible issues are, and where was the big change? Which one of these was the most important to getting you to your goal?
Well, the ambitious part of our plan is we want to act early and strong. So what we do is we take our steep taxes, our carbon price, and we put majority of that money into technology and sustainable resources. So those are aspects that can continue on forward. One thing that we are looking at is we got to make sure those advances happen, and the fragility is if we don't get those. But we already see that a lot of these technologies are advancing at a rapid pace, and with the amount of funding that we're focusing on technology and sustainable resources, we expect that technology that's already growing at a good rate to multiply quickly in order for us to get to a easier level to sustain our
All
quick
right,
approach.
burning questions from the crowd.
I just wanted to add to that.
Oh, you can't do it. You can't add. We're questions. We're going on. Okay, questions in the back.
Hi, you guys say that you plan to reduce other gas emissions from agriculture by 72%, which is very ambitious. How do you plan to achieve this goal?
Right. Well, if you look at the agriculture emissions, it's effectively accounting for about a component of 35% of the overall greenhouse gas emissions. You have the CO2 emitted by agricultural and land use. You have methane, the nitrous oxide, and some F2 gases. And through the technological advances, that's how we primarily hope to cut all of that down, because once you have truly like portable renewable energy, you can move all of those diesel burning tractors and combines and everything over to the renewable energy. And so that's 11% that you can cut down to practically zero once all of that industry is on renewables. And when you're looking at methane, there's also already advances in capturing the methane from cows and other and livestock. There are compounds that can be put actually in the feed that are already capturing at least 30% of what's already produced there, and there are other mechanisms that are in the process of being developed that hope to be able to cut that down to at least 70% in the next 5 to 10 years. And so with the technological advances in those industries, we hope to bring that down. And so that leaves us with the 6% left from the nitrous oxide, and that's just basically used in fertilizer. And so if we can figure out a newer or better way to fertilize our crops, that 6%'s gone as well. And so while it sounds like a lot, you're taking 20% of that 35, or you're taking 25% of the overall 35 and spreading it across several different facets of the agricultural industry.
Okay, one more question from the crowd.
So your GDP actually goes down to 2.4%, and if you're looking at the final chart, the sustainability is also not. So how do you explain growth over a long term based on those numbers?
Population growth.
Growth in population.
GDP.
Right.
Repeat your question.
Well, basically with the GDP being that low, especially coming down, well, it was 3%, comes down to 2.4%. How do you explain the sustainability of your proposal?
Yeah, we looked at GDP growth using per capita GDP growth using World Bank data from 2000 to 2014, and the average was actually 2.1. So of course you've got variability in there that's creating the averages, but that GDP growth is actually higher than the average of the last 14 years. So it's it's mildly aggressive. Also, kind of answering the question about the population sliders. Decrease for us, decreasing population by a point from the baseline scenario, lowering it doesn't really affect global temperature by much at all. For population, it's really all in the GDP. We can go up, and naturally that increases temperature. But 2.4, going lower than that, we really don't get any greater benefit. So as far as sustainability, it's really all about the behaviors that people make. So once we get renewable energy, changes in carbon, changes in agriculture, which will also change the way people eat, because getting them off beef and onto non-ruminant animals, because that's where the methane comes from, you're going to get a way where you keep the population rate at the same, slightly higher GDP. So that's sustainable. That's actually growing the pie of resources that people have.
The 2.4 is higher than the business as usual that was provided in the model, actually. We bumped it up because that was important to us. We made sacrifices in other ways to maintain it.
Okay, thank you for this group.